Next topic we will be discussing is a miniature circuit breaker. We would have heard the word a circuit breaker. The compact size of that is nothing but a miniature circuit breaker. So what is the necessity of that? Have you people ever imagined that whatever the equipments you are using in your houses like fan, washing machine, oven, fridges, etc., whenever the short circuit happens or the overcurrent flows through that, what happens to all your equipments? People ever imagined that? Obviously, if the heavy amount of current flows through that particular cases, right? Obviously, your devices will get burned or led to the fire accidents. So that's why a proper circuit breaker is required to protect all your devices. A miniature circuit breaker is one of the safety device that can protect under such fault conditions. The compact size of a circuit breaker is nothing but a miniature circuit breaker. Its short form is also called as MCB. It works on the principle of electromagnetic mechanism. So this is the picture representing the circuit breaker, miniature circuit breaker. You would have seen the miniature circuit breaker in your houses, right? So then what is the working principle of this? So here you can observe in the circuit we have a cable terminal, a bimetallic strip, we have the coil assembly, the contacts, a cable terminal, the arc chamber, the operating handle. So whenever the overflow of current takes place through the MCB, the bimetallic strips gets heated. So here you can see the bimetallic strip. It's get heated and it deflects by bending. So it will bend and it will be deflected like this. Whenever it deflects that one, this circuit will get opens. Whenever the deflection of bimetallic strip releases, it will release the latch. The latch causes the MCB to turn off by stopping the flow of current in the circuit. So this is how your MCB will work. So whenever the high current flows through that or short circuit current flows through that, the bimetallic strips gets heated and it will deflect by bending. So it will be connected to a latch. So what happens at that time? The latch will get open. Because of that, there will become an open circuit, which will make the operating handle to turn off. So again, if you want to restart that one, we must turn on this operating manual, whatever we have. So that's the inside. You can see here. We should turn on that one manually so that we can resume back the supply. So we would have heard. So many times we would have seen in our houses that MCB has been tripped. Why it will trip? One is because of the overflow of current or because of a short circuit or because of a overloading. Whenever we'll be using many equipments together, it will trip. We will say the MCB has been tripped because of the overloading. Why? We would have taken a sanction load in your energy meter. In the previous classes we have discussed. Sanction load will be taken. Example, we would have taken a sanction load of 2 kilowatt. At a time we can use of load up to 2 kilowatt. We cannot use a load more than 2 kilowatt. Example, the water heater, the rating will be 1 kilowatt to 1.5 kilowatt. If in your house if you have 3 water heaters, so if you are going to on the water heaters, it will be consuming minimum of 3 kilowatt. But the sanction load what you are taken in your house is example is 2 kilowatt. Obviously it's exceeded. Right? Obviously what happens? The MCB will trip. Again, the choosing the MCB is very important because according to whatever the sanction load is there, whatever the rating current flow through your houses, depending on that your MCB has to be chosen. In your houses you would have seen there will be many MCBs. So we can segregate that one into a branch MCBs. For a particular room, we can use a MCB. What all the loads are connected. If you have 2 rooms in your houses, for one room we can use one MCB. For another room we can use one more MCB. For the kitchen we can use one MCB. For the hall we can use one MCB. Like that we can divide that one into a different parts and the branches, and all together connected to a main MCB. Like that we can segregate the MCBs. Then what is the merit of a MCB? So the merit compared to the your fuses, it can easily identify the faulty zone when it is tripped. So that's why I told the branch MCBs. If we are going to use with the multiple MCBs, right? So whenever we are going to trip, we can easily identify where the fault has been occurred or the way the overloading has been occurred. That is the one advantage. And second point is, it is simple to resume the supply. If you're going to compare with your fuses, we cannot simply resume the supply. We need to replace that one with the fuse wire. Then only we can resume back the supply. But here, by using this operating handle, we can manually turn on that one so that we can resume back the supply. Less maintenance and the replacement cost, right? So obviously whenever the overloading occurs or the short circuit occurs, just it will automatically trip. We need to manually trip on, that's it. So there is no maintenance required or the replacement cost is not necessary. And it works faster for the short circuit and the overloads. Whenever the short circuit occurs or the overload occurs, it works very quickly. It is reliable. And power restoration can be done easily, as we already discussed. Simple to resume the power supply. So power restoration we can done manually and we can be done quickly. Then what are the disadvantages? The cost of the MCB is more compared to the fuses. That is the main disadvantage we have. The next one is a slow tripping. Compared to the fuses, here the MCB will work slowly. The fuse will get melted up very quickly because it's a very good connecting material. Whenever the high current flows through that, it will melt down quickly and it will break the circuit. But here the MCB, it will trip very slowly. Then it cannot protect against the earth faults. Whenever the earth fault occurs, it cannot protect or it will not trip. So these are all the main disadvantages what we have in the MCB. Then where we are going to use this? So obviously we are going to use this for the residential purposes. We can use for the commercial purposes. In industries, we can use. Then now we can compare between the fuse and the MCBs. So if we consider with the fuse, whenever the excessive current flows through the fuse, the conducting material inside it melts down, thereby it will interrupt the current to flow through that. This is the working principle of a fuse. Now if we compare with the MCB, it works on the principle of electromagnetic mechanism, which will be present inside the MCB. It will help instantaneously interrupt the current during the faults. So as we discussed earlier, so whenever the short circuit current or the overflow of current will happen, the bimetallic strips will get heated up and it will deflect by bending. Because of that deflection, the bimetallic strip releases the latch. Then we'll have an open circuit. Because of that, we'll have a current will not flow through the circuit. Then fuses other than the rewirable fuses cannot be reused. But if you consider with the MCBs, a miniature circuit can be reused after the clearance of the fault. Whenever the overload happens, we can turn on the equipments, whatever the maximum amount of power we are consuming. Then manually we can turn on the MCBs and we can restore back the supply. There is the advantage compared to the fuse. Next one, if you compare, the fuse acts faster than the MCB. So as we are earlier told in the disadvantages, the disadvantages of the MCB is slow tripping. But if